Now I'd like to talk to you about fractional sections. So first of all, let's discuss what a fractional section is. A fractional section is a section with one or more of the subdivisions of less than 40 acres. And that's due because one or more of the controlling corners was never set for that particular section. Now let's review what a controlling corner is. A controlling corner in this definition is going to be either section corners or quarter corners. So if you're subdividing a section or even staking out a section, and you can't stake the section corners or the quarter corners, one of them, then you're going to end up with a fractional section. Now a fractional section usually happens when the land is invaded by something else, a meanderable body of water, for example, or a township or some other survey that's not part of the public land survey system, where the public land survey system borders that particular thing, whatever it is, be it a meanderable body of water or whatever it is. So you have an incomplete section. Obviously, that's going to make it a fractional section. Now, regarding fractional sections, the law states that the subdivision lines will be run in cardinal directions. Now, we know cardinal directions are true north, south, east, and west. Now, the law presumed that the section lines were actually run cardinally, and we all know that they were parallel with the east township line. Since a resurvey will almost always find those lines out to be other than the cardinal, some adjustments have to be made to allow you to protect the plat and the patents. Now you can see Manual 2009 Manual Section 3-120 for further discussion on this, and I would suggest that you read through that so you can get a better understanding of this part with the fractional sections. Now, when we're subdividing fractional sections, there's three basic methods to perform this process, and with specific applications to each one. And what they are is, first of all, it's the arithmetic mean, or the mean of the two section lines to subdivide the section. The second one is called a weighted mean, and that is a mathematical process to determine where the subdivision of the sections are. And the third one is parallel lines. Now, what we're going to do is we're going to talk about all three of these methods so you have an understanding of how a fractional section could be subdivided in this process. First of all, when we talk about the arithmetic mean, it's simply the mean or the average used to distribute the distance between the controlling section lines in an equitable manner. I have a graphic of this, and I will explain it further in the next slide. Okay, here's an example of an arithmetic mean. Now, this method is best applied when the middle section line is in the center and the controlling section lines are essentially the same length. If you take a look at this graphic, the east section line is 27.45 chains long, and the west section line is 27.5 chains. So you can see that they're just about the same length. So all we're going to do is we're going to find the mean of the two bearings. Now take a look at the bearing of the east section line. It's 0 degrees, 02 minutes northeast. And the bearing of the west line is 0 degrees, 10 minutes northwest. So from one to the other is 12 minutes. So if I was to take that 12 minutes and divide it in two, that's 6 minutes. And I could subtract it from the northeast, which would give me a northwest bearing at the center of 0 degrees, 04 minutes. Or I could subtract it from the 10 and get the same thing from the west line. So what I did is I took the mean of the difference between the two bearings on each side to calculate the bearing of the center of section going north-south. That's how you would do it with an arithmetic mean. Now, in most cases, the weighted mean is the better way to subdivide the section. It takes into consideration the lengths of the controlling section lines, and it's going to mean them accordingly. Now, if you refer back to your knowledge of mathematics, what we're really doing here is like a vector analysis. And in the next slide, when we take a look at the graphic, I'll explain that to you. Now let's take a look at this graphic. The weighted means are especially needed when the controlling section lines vary greatly in length. Take a look at our graphic here. On the east side, the controlling line is much larger or much longer than the controlling line on the west side. So we're going to call the controlling line on the west side line number 1. And we're going to call the controlling line on the east side line number 2, and then the other controlling line, line number 3. Now, controlling line number 2 goes from the section line to the quarter corner. And then from the quarter corner, it's going to a meander corner. On the west line, it goes from the section corner to a meander corner because the line's not long enough to go to a quarter corner. So you can see that there's a lot of difference in the lengths of the two controlling lines from the east part of the section to the west part of the section. So now what we're going to do is we're going to calculate an arithmetic mean, and you'll take a look at it and see in the next slide how we're going to do this. Okay, here's the way we're going to compute the weighted mean. What we're going to do is we're going to calculate a coordinate, or we're going to assume a coordinate at the beginning of line number 1. That would be the section corner. Now, on the controlling line, the west line of the fractional section, line number 1, we have a bearing and distance. Therefore, we can calculate a latitude and departure, and we can put a coordinate on the meander line at the end of line number 1. Now it's as if we're going to take line number 2 and take the beginning of line number 2 and set it on the meander corner, or the end of line number 1. And we're going to calculate a coordinate for the end of line number 2 using the coordinates that we started, and we're just going to continue running coordinates up here. We're going to do the same thing to line number 3. And we're going to put the beginning of line number 3 at the end of line number 2. And once we do that, we're then going to have a coordinate at the end of line number 3. Now we have a coordinate at the beginning of line number 1, and we have a coordinate at the end of line number 3. And we're going to inverse between the two of them, and that's going to give us our weighted mean. So again, we assume a coordinate at the beginning of line 1. And then we're going to stack these lines on at the end of each other until we put them all together. So we're going to have line 1, and then line 2 at the end of that, and then line 3. We're going to calculate coordinates for all those corners, and then we're going to inverse back to the beginning to get our weighted mean. It's just like running a vector with a vector analysis. Now here's a word of caution. Do not use a weighted mean when the fractional section is against a range line, because the range line was put there first, and we're closing on that range line. So in a case where you have a fractional section where you're closing on a range line and you need to subdivide it, as we can see in our graphic, what we would do is we would have the center north-south section line parallel with the east line, and then the other subdivision line for the lots parallel with the east line as well. And in this case, we would also have the east-west center of section line parallel with the south line. Now, the reason that we're making these north-south lines parallel with the east line instead of using a weighted mean is because we're closing on a range line, and we have to keep the integrity of that range line. So we're not going to use a weighted mean on that. And as a rule, the weighted mean is the best way to do these, but this is an exception to that rule. Now, there are some fractional sections where you're not going to have an opposite section line to use a mean or a weighted mean. So what you're going to do in situations like that, you're just going to go parallel with the controlling section lines you have. And we'll take a look at a graphic of this in the next slide, and you'll see what I'm talking about. Okay, let's take a look at this graphic. In this case, the parallel lines are your only equitable solution. So what we have here is we have a fractional section where we have the east section line and the south section line, but because it's a fractional section, we don't have a west section line or a north section line. Therefore, in order to subdivide this particular kind of a section, we would just go parallel with the established controlling section lines. That is, the north-south center of section line would be parallel with the east center of section line, or the east section line, and the east-west center of section line would be parallel with the south section line. And as you can see in this particular situation, because each one of those parts that we segregated are less than 40 acres, all three of them would be government lots. Okay, in this lecture, we've talked about fractional sections. Now remember, a fractional section is a section where one or more of the controlling monuments could not be set. Remember, controlling monuments, we're talking about section corners or quarter corners. If you have a situation like that, then you have three different avenues that you can approach to subdivide that section. You can use the arithmetic mean, you can use a weighted mean, and you can use parallel lines. Now, if you're concerned whether you should use a weighted mean or an arithmetic mean, the default is always to the weighted mean. That's the preferred method of doing this, unless you can't and you have to use parallel lines. So when in doubt, use a weighted mean. Also, this is the end of our 8th lecture or our 2nd week. What I would like you to do now is go and use our worksheet, go through the worksheet and work that out. When you get finished with that, then let's move on to the next lecture and the next week's lectures.